For this video, I'd like to talk about the concept of simplifying square roots. So there are some square roots that you can find a nice clean answer to or a whole number answer to, like the square root of 4 or the square root of 9 or the square root of 16 and so on. And remember, square root is just asking what number multiplied by itself gives you the thing on the inside. So 2, since 2 times 2 would be 4. In this case, it would be 3, since 3 times 3 is 9, and 4 times 4 gives you 16. So that's the basic idea of square roots, but essentially all the square roots between 4 and 9 or between 9 and 16 are going to have decimal answers. So for instance, the square root of 2 is like 1.41 something, and it actually goes on forever. These are what are called irrational numbers. So it does not have a pattern in the decimal, and that decimal will just go on forever in kind of like a random sense almost. Irrational just means it cannot be written as a fraction. And for all of these that do not have whole number answers, ultimately you kind of need a calculator to be able to figure out its decimal approximation. And there are other ways to find the value of it not using the calculator, but they're typically more advanced than a high school class. So the question is, what do we do for these numbers that are irrational? Is there any way to simplify them? And sometimes there is. If it's, for instance, like the square root of 2, this is as simple as we can make it. But something like the square root of 40, there are methods to actually simplify it and essentially in a way pull numbers out of the square root. And so that's what we're going to focus on in this video. And the basic idea is, with the square root of 40, you want to think, what numbers multiply together to give you 40? Because some of those numbers you can actually take a square root of. So 40, for instance, is just 4 times 10. And when you have a product under the square root, we can break this up into a product of square roots. All right, this will always work. This is always true. And you can see it's true because, for instance, let's use numbers that we can actually take square roots of. Let's say we have the square root of 9 times 4, which would be root 36. And 6 would be the answer to that, since 6 times 6 gives you 36. But since we have a product here, we could also break it up into the square root of 9 times the square root of 4. And the square root of 9 is 3. The square root of 4 is 2. And so you see, you still get the exact same answer of 6. So since we have a product, we can break it up into a product of square roots. But this only works if you have multiplication or division. If you have addition or subtraction, this no longer works. And let me just show that to you so that you can avoid making that mistake. Let's say you had the square root of 9 plus, actually let me make sure this is all underneath the square root. Let's say you have the square root of 9 plus 4 under the square root. And if you add them first, you get the square root of 13. But if you try and break them up into a sum of square roots, like root 9 plus root 4, this is no longer equal to what you originally started with. Because the square root of 9 we know is 3, the square root of 4 is 2, and so we get an answer of 5 when we do it this way. But the square root of 13, that's going to be between 3 and 4. In fact, you can put that into the calculator, and let me do that really quickly. So the square root of 13 would be about 3.605, and again, it's irrational, so its decimal approximation is going to go on forever, but it's definitely not equal to 5. And you can try this out with whatever numbers you want, but if you have a product, you can break it up. If you have a sum or a difference you're subtracting, you won't be able to break it up into two square roots that are added or subtracted together. So with that in mind, let's go back to our problem. Once we're able to break this up into a product of square roots, then some of these we can actually take a square root of. Like the square root of 4, that's 2. So this just becomes 2 times the square root of 10, or we could say 2 root 10 is how a lot of people will say it. And we could try to do it again with 10, but 10 is just 5 times 2, and if we split that into root 5 times root 2, these are both prime numbers, and they don't have nice, clean square roots. Or if you take their square roots, you're not going to get a whole number out of it. So it's really not worth it to break these up. And in fact, we'll just kind of stop right here. So the square root of 40, when we simplify it, becomes 2 times the square root of 10. And you might be wondering what the point of this is. And there are many reasons why this would be advantageous. But ultimately, if you want a decimal approximation, it doesn't necessarily matter if you simplify it or not. I mean, if you put both of these into the calculator, you're going to get the same answer. It's like 6.32 something. Let me just write that down, 6.32, and then its decimal goes on forever. It's irrational. But a lot of times you'll be, let's say, dividing this by 2 or something, and being able to pull the 2 out, we would then be able to cancel them out, and you would just have root 10. So there are some instances where it does make a lot of sense to do this in terms of simplification. Now let's go through several other examples just so that you can get the hang of this.